I think one of the things that's been challenging is putting aside the interdisciplinary, the other subspecialties, showing the a return on investment or even a KPI, key performance indicator with these AI algorithms, is that it's clear it's a very challenging. I mean, we've looked at lots of different things, turnaround time, and it's been difficult. We have a few things that actually I'll share that actually are very promising, but I think one of the fundamental issues is that we're looking for metrics to change when we fundamentally have to figure out as radiologists how we can use these algorithms to best advantage in order to affect the change of whatever parameters we're looking at. Because I think it's all too common. We deploy, and this is why we changed our approach to how we use the algorithms. We would put it in, we would have a demonstration as to how to use it. In other words, what do you click on to see the widget or whatever it might be. But we didn't really tell people what they should be doing with it. But without telling anybody how to use it, then what happens is, nothing really changes because you have somebody dictating a report the same way, and then sort of integrating maybe either before and after looking at it, and nothing's changed. So when you look at it from that perspective, it's probably not surprising actually if that our metrics don't change all that much, or it's hard to find. We have found some. So I'll give you an example. With we have a chest X-ray algorithm that we use through looking at endotracheal tubes. And we actually found that once we integrated that in, when we had it in our system, we let the residents know, especially this is an overnight issue, we actually found that it decreased the amount of time it took to actually notice that there was an issue with a particular X-ray. And it decreased the time proportionally more for the positive cases, and it actually decreased the time a little bit for the negative cases, I think by like a little less than 10%. But the positive cases, almost 20% decrease in time. And so that showed that we were able to potentially tell the clinical team that there was a problem with an endotracheal tube sooner with that algorithm in. So that's an example where you have to communicate what you should do with that particular algorithm, or else it's going to be hard to affect change. Another one, which I think has made a big difference, is in our lung nodule algorithm that we use. And many of our cardiothoracic radiologists do not do independent lung nodule surgeries because it's so sensitive that what they find is that they're actually throwing nodules out because it's so sensitive. And so they've offloaded that particular task and have concentrated on other things. Maybe they're deciding whether the lung nodule is malignant or it's benign. But that's another example of where changing fundamentally what you do may change. In that case, it could change the turnaround time metric. That's actually one particular thing we'd like to study, but it may change some metric in a different direction. So I think there are different ways to look at these things. And you mentioned the collaborations with other subspecialties. Cardiology is an example of one. With a coronary artery calcification algorithm, if we're able to get those incidentally found high coronary artery calcification patients and get them to cardiology sooner, we may be able to get these patients stay out of the ED, maybe not have inpatient stays because they're having heart attacks that we would have caught sooner. And that is a potential metric worth looking at. In preliminary studies we've looked at, we've shown that these patients are incidentally getting more management, without which they would have gotten no management. And so we're still collecting more data on that, but that's just an example. You can see many other use cases, whether it's bone demineralization, maybe AAA, aortic aneurysm, identification, incidentally. So all kinds of use cases that we could move the dial on.